Welcome to the DIY Honda Garage channel. The DTC P0616 indicates an issue with the starter cut relay 1 control circuit, specifically a low voltage condition. This trouble code arises when the powertrain control module, PCM, detects that the return signal from the starter cut relay is less than expected while the starter is in the off position. The PCM acts as the brain of the vehicle's engine management, monitoring various components to ensure proper function. The affected starter cut relay is located within the relay circuit board, which is typically positioned close to the battery or fuse box in the engine compartment. The importance of the starter cut relay lies in its role to prevent the starter motor from engaging inadvertently, protecting the vehicle's electrical system and enhancing safety. Diagnostic procedures aim to pinpoint where the failure is occurring in order to rectify the low voltage issue. The DTC P0616 highlights a malfunction within the starter cut relay 1 control circuit, typically residing in the relay circuit board under the hood. The primary function of this relay is to control power to the starter motor, allowing or preventing it from functioning based on signals received from the PCM. When the PCM detects a low voltage return signal from the relay while it is in the off state, it flags this discrepancy as a fault and stores the DTC. The position of the relay circuit board is crucial in diagnosing this issue, as it affects the flow of power throughout the starting system. Understanding the role and location of the starter cut relay and its connections to the PCM is essential for effective troubleshooting. Several possible causes can trigger the DTC P0616, starting with a defective relay circuit board. The relay itself may suffer from internal faults, causing abnormal voltage readings. Misconnections within the relay socket or wiring harness can also lead to incorrect signals being sent back to the PCM. Further, the PCM itself, being the controlling unit, might experience a failure or internal error that presents as a low voltage signal. Each of these potential issues must be ruled out systematically, as they can manifest similarly during diagnostics. Identifying the root cause is critical to restoring proper relay function and ensuring reliable vehicle operation. The symptoms associated with the DTC P0616 are primarily centered around the vehicle's starting capability. One common issue is that the starter motor may become completely inoperative, preventing the engine from cranking at all. Drivers might also notice an error message displayed on the dashboard, alerting them to an electrical or starting system malfunction. Additionally, the vehicle may experience a no-crank condition, where turning the ignition key yields no response from the starter system. These symptoms can lead to confusion and further troubleshooting if not appropriately diagnosed, emphasizing the need for careful inspection of the starter cut relay and its connections. The first troubleshooting step involves turning the vehicle to the on mode, enabling the diagnostic capabilities of the PCM to initiate. Once in this mode, the technician should verify that the starter cut relay is functioning properly, ensuring it correctly responds to control signals from the PCM. Monitoring the return signal from the relay is crucial at this stage. If the signal remains low despite the vehicle being in the on position, further investigation into the relay circuit or connections would be warranted. Documenting the results from this initial test can guide subsequent troubleshooting steps, ensuring a systematic approach to isolating the failure. In this step, the technician will disconnect relay circuit board connector B, specifically the 12P connector, to gain access for inspection. With the connector removed, the next step is to check the IG1 starter cut circuit for proper voltage levels while ensuring the ignition is turned to the on position. A correct reading should indicate a voltage of approximately 12 volts, a clear sign that power is reaching the starter cut relay system appropriately. Any deviation from this expected voltage directly points to a potential issue within the external circuit. Identifying whether the voltage is present helps in pinpointing the faulty component. For this stage, the inspection extends to the ST-cut RLY1CL circuit, requiring disconnection of both relay circuit board connector B and PCM connector A. After ensuring both connectors are disconnected, the technician should proceed with inspecting the ST-cut RLY1CL for any open wire conditions. A resistance check is performed, and a reading of less than 1 ohm indicates no issues, while higher resistance may suggest potential faults. Inspecting for shorts to ground is also crucial, as readings above 1 mega-ohm would signify that the circuit is intact. The results from this step clarify the condition of the circuit and highlight whether further actions are necessary. In the final troubleshooting step, the technician focuses on an inspection of the powertrain control module, or PCM. Following the completion of previous inspections which yielded normal results, it can be reasoned that if one remains abnormal, the PCM is potentially the source of the fault. The technician will evaluate the PCM's functionality to see if it's transmitting and receiving signals correctly. Any signs of failure located at this point would confirm that the PCM is defective and likely needs replacement. A careful analysis of the PCM state is essential, since this component oversees many aspects of the vehicle's operation, and malfunction affects broader systems. After completing the necessary repairs, it is crucial to clear any diagnostic trouble codes, or DTCs, stored in the PCM. This can usually be done with a diagnostic scan tool that resets the PCM's memory. Following the clearing of codes, a test drive should be conducted to ensure that the vehicle operates normally without any return of the previously indicated faults. Monitoring for any unusual behavior during the drive will help verify that the issue has been fully resolved. It's essential that technicians remain vigilant for any return signs of the DTC P0616, as unresolved issues might signify deeper systemic faults. To prevent the recurrence of DTC P0616, carrying out regular maintenance is essential. This includes routinely checking the battery's condition, as a weak battery can contribute to poor voltage readings in the starter cut relay circuit. Technicians should also inspect relay connections for corrosion or wear, ensuring that all terminals are clean and secure. Maintaining proper voltage levels throughout the system enhances reliability and performance, significantly decreasing the risk of failure. Documenting maintenance checks can also help identify trends or recurring issues, allowing technicians to address them preemptively before they escalate into serious malfunctions. In conclusion, effectively diagnosing DTC P0616 involves a systematic approach to identify the source of the low voltage in the starter cut relay 1 circuit. By understanding the role of key components such as the PCM and the relay circuit board, technicians can accurately pinpoint the malfunction. Addressing any issues within the circuit requires meticulous inspection of both the relay and its connections, as well as thorough testing of the PCM. Post-repair, it's vital to perform preventative checks to ensure ongoing functionality and reliability of the starting system. Such measures not only improve vehicle performance, but also enhance the longevity and reliability of crucial components, giving drivers peace of mind. Please like and subscribe to the channel. See you next time.